So this is the box. So this is the box we created in the CAD software. After that, while saving actually, we will save it as STL. That is the format we use for the 3D printing actually. What it will do is it will create all the CAD geometry into triangles actually, each and individual triangle. So we will create that. After that, this is a slicer. As there is a CAD software, this is other software which is called a slicer. This is from Pura actually. There are many kinds of 3D printing slicer software which will help like convert the CAD geometry into the G codes. The mechanical guys may know like we use CAM software while doing the machining parts. That's the same property here. So we will divide part into two different parts. One is a functional part which needs strength. The second one is the aesthetic part, like which needs a good look, which is used for the maybe some kind of ornamental purposes, something like that.
If you can see this Jaguar, this is a aesthetic part because you might want to give it to someone who wants it to be kept on a table, desktop model. So this doesn't need strength, whereas take this as functional as well as aesthetic. This is a katana
This is a katana from One Piece. So many people may know. This is actually.
I can show this to everyone and all the actions. But please listen to this first.
So the main thing is aesthetic and strength, right? So we need strength from the inside. So for the strength parameters, I will start with the quality parameters, that is the aesthetic parameter. We have the layer height. Like layer is 0. First layer. This is the actually printing process. This is the first layer, so that it will stick on to the base of the 3D printer and it will move onward like in the Z direction. If you see actually this green line represents the X, the red line represents the Y, and the blue line represents the Z. So for the quality, if you remember the parts Akhila was showing, there was a layer line visible, right? To remove the layer line visibility, we are decreasing the layer line thickness. I mean, in between each layer there is less space, so that it will be smoother. So this is the 0.28 layer height, like that is 0.28 mm in terms of mm, like 0.280 microns. So if we reduce it to 0.12, that is like 120 micron, the layer height should be smaller and the part should be like aesthetically more pleasant actually. So if you see, you can't see the layer lines now. I mean, if you zoom it too much, you can see the layer lines. But each and individual layer, the layer lines are less visible now. 0.28 whatever. So you can see the layer lines thickness has increased, right? So for the functional parts, this may not be a main issue, but for the aesthetic parts, this is the main parameter which we are looking on. The next one is line width. That will be governed by the nozzle diameter. So we will not tweak that. We can tweak that, but it is not a important tweak to the part. Next actually are the walls. The green and the outer perimeter of the part you can see, right? That's the wall we are producing. The red one is called as outer wall. The green one is called the inner wall. Can anyone say like what's the importance of wall to the house or something like that? Cover, yes. Finishing, yes. And strength also, right? There are wall bearing structures. Like if you don't have the beams and all, you can load the part on the wall itself. So you can increase and decrease the number of walls also. Like currently it is 2 walls. If you increase the number of walls, the perimeter will increase, so that the part will be stronger. There is a one model which is circulating, which has around 20 walls or something. It has more strength. Shashank. Hello, sir. So if you can see this, it has only walls. There is no infill, so it has more strength.
With this setting, you can practically keep the infill 0, but it will still have more strength.
But we are looking in the 3D printer or in any.
I did my mechanical engineering in Vidyavadaka College in Mysore. And after that, I did my masters in industrial automation and robotics of mechatronics branch in Bhopal University. After that, for the masters project, I did industrial internship 1 year in JCB company. There, the project was to automate JCB machine and operate it using hand gesture wirelessly. Usually the operator sits inside the machine. My project was to operate it externally. Machine will be elsewhere, the operator will be elsewhere. So it was a radio controlled communication, sensor controlled project. And after that, I worked in 2 companies. One was a drone startup company in Mada called Geomet Technologies. The mold made a pattern made of completely carbon fiber, pure carbon fiber part. I know it's a sustainable work. So the previous session before the break, you learned about the basics of slicing software: speed, layer height, and temperature, walls, infill. Next we will go on to speed. We're just starting. So Shravan had explained about 2 different materials, PLA and PETG. Do you still remember the full form of the materials? PLA is anyone? Good. PETG? PETG. It is the same material as juice water, coffee water, PET, PET water, but there is an addition of G. G is glycol, and glycol is added to the material so that it is easier to print. So it is called polyethylene terephthalate glycol, PETG. For PETG parts we use slower printing speeds, and for PLA parts we use higher printing speeds. So as you can see here, there are different parameters in under print only, like in under speed only. So if you set a print speed of 50, not everything prints at 50. Take the example again of building only. If you can lay bricks very quickly, but you can't make roof and floor at the same speed, that will take time, that will take longer time to cure, to place with proper measurement. But bricklaying, if this one wall is taken for example, this one wall can be finished in half a day, but this whole flooring, the floor and roof will take probably 1 week. So there are different printing speeds in 3D printing also. Here you can see the part. The part generally is shown in yellow color, and it is this same part that you already saw. It is a GoPro camera mount. When you go to the you can see the outer material is in red color, the inner material is in orange, green and yellow. So yellow is the top part, the outer wall is red color, the infill material is orange, and green is the inner material. This is purely for representation purpose, so that in the other tab when we saw in prepare, the whole model was seen in yellow. But in the preview section you can see which part of the 3D printer in terms of lines are represented in which color, so that when you give the settings here, you can better judge and tweak the settings. First is print speed. You set the print speed and it is always in mm per second. Maybe in America it's in feet or centimeters, inches per second. But in metrics it is mm per second. This is the general print speed. After that, infill speed. What speed the infill will be printed at? Next is wall speed. Outer wall and inner walls are also selected. Outer wall is 25, inner wall is 25 because, as we had told, walls also take the main structural load of the part, and walls add to the aesthetics. So even though the general print speed is 50 mm per second, the walls are printed slower so that it comes out beautifully and the layer adhesion is good so that the print is strong. And there is top bottom speed. The yellow layer that you see is the horizontal layer, top and bottom. Bottom is the base and top is the how many layers you give at the top to close the part. And then there is travel speed. What can you guess what travel speed is? Because printing speed is one, travel speed is good. What he said is when the print head moves between different parts. These purple lines that you see are travel lines. Here, the print head of the printer doesn't extrude the material; it just travels from one part to another. What essentially it means is this is one part, and this is one part as seen in the printer. From here to here, it is not printed, but it is just merely traveling at a very high speed. So, even though here it is printing at 50 mm per second, from here to here it may travel at 100 mm per second like this, very fast. The most important layer of a 3D printing in FDM 3D printing is the first layer. It is called the initial layer. It is like the foundation of a building. So, if the foundation is strong, the following layers will be very strong, and like the building or the part both won't fall. So the initial layer needs to be very slow. Here the initial layer speed is 20, less than half of the main printing speed, and it needs to stick to the printing bed normally. After the initial layer is printed at 20, all the subsequent layers are printed at 25, 30, 50, whatever print settings are given. See here the print speed gradient is given, and this line type, the color has been changed as per printing speed. So this is blue is 15 mm per second and orange is 150 mm per second. First layer is printed at 15 mm per second so that the foundation of the part is well established. As you keep going higher, traveling speed is 150 mm per second. Infill is printed at around 30 mm per second. And top bottom layers are also printed at around 40 50. So that's how printing happens. And the
you can also stop and you can adjust. I'll show you how to the bed level matters. There is a setting called Z offset that moves the nozzle up and down. Okay, I'll change the Z offset. Right now it is minus 2.43. I'll reduce it to very low. Okay, say I'll reduce it to 2 or even low. Remember the previous number 2.43. So I'll reduce it to 1.9. Okay, once I change anything, I'll have to say save settings, and you have to readjust. Now you can see the filament, the bed level, it's a bit down. That means the nozzle is at a bit of height compared to the previous speed. And you can also change the nozzle temperature and speed. Right now, in the display you observe here at 100%. This means that it is running at 100% speed. You can also change the speed here when you go to adjust. Change the speed. Let's say I want it to run at just observe the speed right now. I'll reduce it to 50%. And then observe the speed. See, it has started to move very slowly to the right. So similar to that, you can change the fan speed 67% it is at right now. You can do it 100%, and you'll able to notice the change in sound.
So this thing keeps on printing layer by layer like this. All the infills are printed, all the walls are printed.
And you can also change the bed temperature and also temperature depending on your requirements. Say if the filament is not getting extruded properly, that is, you anticipate a certain amount of filament to come out of the nozzle. It is not coming out properly. Then you can increase the nozzle temperature so that it will melt the filament more properly, and it will help push the filament properly. Okay.
How many set will print?
So that is how it will print, the whole printing process. If you have any doubts, ask now.